Bismillah ar-Rahman ar-Rahim. In the name of Allah, the most gracious, the most merciful. Myself, Muhammad Sharif Haider, and I am a student from Afghanistan. It's my third semester in Asian Institute of Technology. My field of study is ICT. So today I would like to propose my proposal, which is based on air quality monitoring using nano sensors, as well as the real-time analysis of these sensors and using nano sensors and GIS, which I have done for Kabul city. So my advisor is Professor Gabriel Louis Horniak. I thank him in advance as he has helped me a lot in conducting the proposal. So let's come to the outline of my proposal. First, I would like to show you some of the contents which will be covered in my presentation. It's the introduction, and introduction consists of three parts of my presentation. That's the statement of problem, my objectives of my proposal, what are the scope and limitations of my proposal, as well as going to the second point, that's the literature survey which I have conducted in completing my proposal, and the methodology which I have used here will be shown, as well as the overall timeline of my proposal project, as well as the budget which is required here for conducting the project. I have also mentioned the references which I have referenced in finishing successfully my project proposal. So first, let us have a short video on the current air pollution problems in Kabul city.
بنظر ما هوای فیلی کابل که ما ملاحظه میکنیم یگانه علتی که محیط ما شما را آلوده کنه چند چیز هستن. یکی زباله های شهری هستن، کلینیکی هستن، و دیگه امو تیل ها و محروکاتی که در انجین های احتراق داخلی مورد استفاده قرار میگیرن او هستن.
So coming to the introduction part, what's air pollution, what are the impacts of air pollution, and analytical and gas sensors, what are the difference between using these two types of sensors, what are real-time monitoring systems, and what is the current use of nanotechnology as sensors for monitoring the pollution in real time, as well as for giving real-time data, map data. We have used also GIS for citizens of Afghanistan, as well as the policy makers who can decide well when to publish the information to the citizen, and what as well as they can use this data for making policies against air pollutions. So this is a comparison chart between analytical and gas sensors. As you can see, normally analytical instruments like GC and ultraviolet spectrography is also, there are lots of advantages and disadvantages because of resolution. In terms of resolution, they are very excellent, as well as cost, but at times when you are comparing it with the cost of analytical station, it's very high. The size is in very bulk, so it's very difficult to manufacture lots of an implementation, and as well as the rigidity is fragile. Process control is very difficult as they are very huge stations, and mass production, as I have also mentioned before, it's too difficult to handle. For measurement purpose, it is instantaneous because it is unable to be real-time processing is unable because we could not just now before implementing this project proposal, there were certain stations which were implemented by the joint efforts and joint collaboration of the Norwegian embassy as well as the Asian Development Bank. So I will go to it further in the coming slides. So if you will go to the gas sensors, you can see which I have used in my project. They are very comparable in resolution, as well as you cannot distinguish it as far as excellent like resolution in analytical instruments. Cost is fair, size can be compact, and rigidity is rigid. So it's very easy, the process control is very easy, and the mass production is easy, as well as the measurement can be continuous. So geographical information system is an information system whose core functionalities include the storing, capturing, and analyzing manipulation of spatial data, otherwise known as geographical data. It is a huge discipline incorporating broad academic discipline in the field of geoinformatics. Geographical information system, as the term mentions, this is a recent development in the area of information system, mainly through maps which are incorporated in internet for the purpose of mapping. So we have used GIS for giving special information of the sensors and its data collected, so that the advantage of GIS for this as well as for other projects is that citizens can monitor or they can get information anytime at their home and anywhere through internet. The application of GIS includes tools which enables users to produce interactive queries for analyzing spatial information. As you can see in the fast era of internet, it's very easy to query something. So what is the advantage and the main reason why we have implemented the GIS in our sensor is that a citizen can query any type of questions or information which they want for a particular place or a particular time, as well as the feature or the coming broadcast of the pollution data. So this is the flow chart of the GIS setup, as you can see, and this it consists of 3 tiers, and the first tier is the middle tier, and the second is the front tier, which you can see the client side browser. The client just writes or in the URL gives the data, the information, the address of the map, and just click enter, and this request is then carried on by map or WMS server in the middle, which is integrated with PHP compiler as well as PostGRE SQL function. So this middle tier is just like an interface between the client side as well as the server side. On the server side, there are huge servers for database in which PostGRE SQL queries are run in order to update and insert and perform many different types of operations concerning the GIS data, as well as the shape files of the data, which we will cover in the coming slides, are also located here in this database. So anything which is queried by the client side is handled by a WMS server in the middle tier and carried on to the backend tier, and from there this request is again accepted and again given to the client and displayed on their browser. So this is the study area which is Kabul in my case. As you can see, this is just the map of Afghanistan, and Kabul is the northeastern part or the northeastern province of Afghanistan, located and its boundaries with Nangarhar or Jalalabad in the northeast, as well as Lagman and Paktia and Logar in the south, as well as the other problems you can see in the map. So we are just concerned with Kabul now. So let's go to the GIS map of the Kabul city. As you can see, this is the city of Kabul, which can be clearly viewed, and these are the legend. We can see these are hills around the city and the highways with the or lines, and this violet circle square, you can see this is the city centers, and this blue is the settlements which are in the middle of the city. You can also see certain brick kilns with red circles and red spheres, which are brick factories located in certain parts of the city, as well as the pink color. You can see it, the purple, I mean the purple color shows the location of industries in the city. So our previous study is the NEPA, or National Environment Protection Agency, an Asian Development Bank with Norwegian Embassy. They have conducted a survey in gathering the information related to the pollutants in Kabul city. So we are just going to show the monitoring sites which they have located for performing the assessment of the monitoring stations. You can see there are 8 different types of monitoring stations which are implemented in different parts of the city. As well as this green is shown, and it is a Norwegian embassy located in the middle of the city. So we go to the results of the assessment which they have done by these monitoring stations, where nitrogen oxides and sulfur dioxides were found as the major pollutants of the city. Over 60% of the public have been subjected to these levels, which exceeding 120 microgram per meter cube of nitrogen oxide, as well as 20 microgram meter cube of sulfur dioxides. So the greatest value which have been collected overall in the city was the average of nitrogen oxide was 704, which is a very, very high amount in this city. The nitrogen oxide emissions are estimated at 16,183 tons per year, which was calculated, as well as, and the sulfur dioxide emissions are 2,484 tons per year. So these are the data which we have already received from the monitoring sites conducted by these 3 projects agencies, mainly NEPA, ADB, and Norwegian Embassy. So after seeing the assessments, this is the statement I have conducted, the statement of problem for my proposal, that reports generated from these monitoring sites are inaccessible all times to PCD, that or Pollution Control Department. Why? Because they did not have any GIS, so they had just static results, and it was unable for the policymakers to monitor these sites. Number 2, the problem was citizens of Kabul don't have any access to air quality data. The citizens were completely deprived of this access of the pollution data. They could not know what's going on and what type of pollution and what type of pollutants are present at their areas. As well as the costs of traditional monitoring station, which we have observed, the 8, in our case 8, is very high, so it is very difficult to install this huge traditional monitoring stations, and all areas were not covered by the monitoring sites. So these were the problems which we observed in this project, and our objective is to provide real-time data for NEPA, that's National Environment Protection Agency, and policymakers for setting policy regarding the air control, and to provide real-time data to the citizens in order to make increased awareness and enhanced public participation. So these are the major 2 objectives of our study, of our proposal, or which will be the first one is just an real-time data for NEPA, or the policymakers of environmental organization, as well as the second objective is the acquisition of data by citizens in order for increased awareness as well as participation in public. So this is the literature review which I have conducted, that's nanotechnology and certain introduction of solid state sensors and how do they work and their mechanism, as well as GIS and Internet GIS, which I have already thrown some light on these terms. So let's come to nanotechnology. As you know, nanotechnology is the science, engineering, and technology conducted at the nanoscale, which is about 1 to 100 nanometers. Nanotechnology has been applied to several industrial and domestic fields. For example, applications for gas monitoring system in our case, as well as it's also used by gas in order to detect gas leakage in factories, and as well as fire and toxic gas detectors is another application of nanotechnology. It's also used for ventilation control and alcohol detectors, as well as it's also used for in studying solid state sensors. So what are solid state sensors? Solid state sensors, from the name itself, it is very obvious that a type of solid substrate is detected by the sensor, as well as signals are passed from this substrate and it is shown on the device. The sensor used for detecting air pollutants are usually produced simply by coating a sensing metal oxide layer on a substrate with 2 electrodes. With 2 electrodes, we can just make a substrate over the device which we are using. In our case, the sensor is just like a solid substrate which will be covered with 2 electrodes on both sides. So how does it work? What's the mechanism? It's just whenever the pollutant is subjugated to this sensor, what happens is that it's changed the resistance and conductance of the sensor occurs when this gas pollutant is observed or it comes in contact with the sensor. When the metal oxide sensor absorbs this reducing gas, it will be carbon monoxide or hydrogen, the depletion area of the surface will be decreased, meaning that the conductivity increases. On the other hand, if a metal oxide sensor absorbs such as an oxidizing gas, the depletion zone at the surface will be increased, meaning that decreasing conductivity. So basic mechanism in these sensors is just the increasing and decreasing of conductance and resistivity in the form of in the form of hydrogen and carbon monoxide pollutants. So as we have to summarize or to conclude, again, the solid state sensors, whenever it is come into contact with nitrogen oxides, which is a depletion zone, depletion gas, oxidizing gas, so what happens is that the surface will be increased in the sensor, which means that the conductivity decreases. On the other hand, when it is exposed to reducing gas like carbon monoxide, depletion area of the surface decreases, but what happens on the other hand, the conductivity increases. So within this simple mechanism, our sensor works. This is the methodology which I have used in the proposal. Like you can see here, it's a nano sensor evaluation kit, and this nano sensors, when air sampling or air pollutant comes in contact with this sensor, it is then converted from this analog to digital converter. So this digital nitrogen oxide concentration is then connected with a PDA or personal digital assistant. It's also connected with a GPS which is integrated in this device, as well as this PDA has the base map and admin boundary, population and urban settlement maps within this database server, which we have already discussed in our previous slides. So what happens here is that the sensors are connected with the GPS. So any concentration or increasing or decreasing of the pollutants is changed into digital concentration, and this is then uploaded to PDA with the real-time GPS. So what happens is that it gives a blink on the map which shows that the higher or the lower concentration, and it goes further, as well as this is then generated by a report which will be shown to the citizen as well as the environmental protection agency of the country or of the city, in our case the Kabul city. So this is, as you can see, it is a map of Kabul city, and these are the sensors, the blue, the green, red and yellow. This color is then generated by higher, lower and medium concentration of the pollutants. This means that the areas with the red dots, filled circles, we can say here, this shows that this area has lots high concentration of the pollutants. As well as when it comes to yellow, it has little, it's come little, and orange come decreases. So the blue is the most, so the green is the most safest area in which concentration of the pollution is less, and in second place it's the blue area, which is also safe, in which pollution control, so the pollutants are very less. So by defining and seeing this legend, we can see that where we can go during our days, so we can plan where we can so we can plan accordingly with these maps. As you can see that where I can go for a picnic or for somewhere else, and where I will be exposed to higher concentration of the pollutants, it's visible in the map. This is just a high image or maximized image of the map. You can see these are the sensors are located in industrial area near the Kabul International Airport, and this is the Wazir Akbar Khan Hospital here in Shahr-e-Nau Park. This is Safa City Center, Kabul Technical University and Rabbani University, and you can see here Afshar Hospital. And so this I have already described. The yellow, the red is the highest concentration or hazardous. We can treat this as hazardous area. It's very dangerous area because concentration is very high in this area. Then it comes to the second position, comes to the orange, which is very unhealthy, less than the red one. Then we categorize according to the third is the yellow, which is unhealthy. Then the green is the moderate. So as far as the final is the blue, which is the safest and the lowest concentration of pollutants here. So we can, by generally looking at the map, we can decide which is the most safest and the most hazardous area. So in conclusion, since the country had no independent monitoring station of its own, and the air quality report was generated by the Norwegian embassy and then by the joint project of Asian Development Bank and NEPA. So they had one problem, that it could not generate real-time reports. So in order to get real-time reports, this work was proposed, which help in real-time monitoring. For these reasons, this particular effort is aimed to build up a simple monitoring system by using low-price portable gas sensing system. One of the advantage of this sensor is that it can be replaced soon with a very low price, because one of the cost of sensor is not more than $100, so it's very cheap. So later all of this modeling could be described a ready air pollution monitoring system that is going to be ready to support the PCD or pollution control department to adjust or even extend the present PCD air quality monitoring stations to facilitate the issue of monitoring station analyzing. So this can be implemented in any provinces of Afghanistan, mainly, for example, in the metropolitan provinces like Herat and Mazar-e-Sharif and Kandahar, Helmand, as well as in our tiny Khost. We can mention it here. So this is the final slide. So not the final, but we can see the timeline which I have given, the activities which I have conducted. And this is my timeline, like the report submission and proposal defense, data collection will be conducted in these 3 months. Sensor implementation will be done in this. Paper writing on this on this proposal will be also done in these 2 months. Final thesis defense will be done in April. And these are the budget of my project. Like the nano sensor it will be 200 per node, and PDA is $100. Printing expenses 32, and total $332 per, which will be completed within this budget of my proposal. So gratitude and thanks to my professor, that's Louis Gaber Horniak, for being patient with us throughout the semester and his valuable guidance. Thank you once again. And if you have any questions, please these are the references which I have referenced in my proposal. Thank you.